addition and subtraction. Let's look at addition and subtraction for numbers in standard form. Right. So, for example, we have something like 3 times 10 to the power 2 plus 5 times 10 to the power 2. Now, for these ones, they are quite simple because we know 3 is being multiplied by 10 to the power 2 and 5 is being multiplied by 10 to the power 2. So if this is the same, 10 to the power 2, 10 to the power 2, we can simply factor that out, that's 10 to the power 2, right? And then add 3 and 5 directly. 3 plus 5, then I get 8 times 10 to the power 2, right? It's all the same, right? So the same thing can be done for subtraction. As long as the powers are the same, right? If we have 3 times 10 to the power minus 5 minus 1.3 times 10 to the power minus 5. Both of these are multiplied by 10 to the power minus 5, right? So we can simply factor out our 10 to the power minus 5 and have these subtracting directly. 3 minus 1.3, that's 1.7. Then we can bring that in times 10 to the power minus 5. So when these powers are the same, it's quite simple. You simply factor out, right? But you can have situations where one of them is smaller, right? So let's proceed to that. So for example now, if I have 7 times 10 to the power 2 plus 4 times 10 to the power 3, now I have a 10 to the power 2 which is not the same as the 10 to the power 3. So what do? I take the smaller one, okay? There's 2, there's 3. What's smaller there? 2. That's what I factor out. I factor out times 10 to the power 2. So 7 was 7 times 10 to the power 2. So since there's already a 10 to the power 2 there, I'll just write a simple 7. But 4 was 4 times 10 to the power 3. Here I've written times 10 to the power 2, meaning that from 10 to the power 3, 10 to the power 2, there's still another 10 to the power 1 left with 4 because I factored out 10 to the power 2. So 4 now remains with a 10 to the power 1 because I've only factored out 10 to the power 2 out of the 10 to the power 3. So now I'll have 7 and 10 to the power 1, I will convert it back to its original form. 10 to the power 1 is the same as 10. 10 times 4 gives you a 40. Then 7 plus 40, that's 47 times 10 to the power 2. Now you need to be careful here. This number 47 times 10 to the power 2 is not actually in standard form. It appears to be in standard form, but it's not in standard form. How so? The comma is not between the first and the second significant figure. So I need to go a step further to convert this 47 to standard form, right? So this will become, let me just write it first, 47 times 10 to the power 2. If I deal with 47 alone, I will have 4,7 times 10 to the power 1. This alone. Then I can bring that times 10 to the power 2 here. Once I've done that, 4,7 remains 4,7. Then these two, by the laws of indices, the powers will add. And then I'll end up with 4,7 times 10 to the power 3. Right? So it's hopefully a simple to understand procedure. Now, let's try another example. I have 2 times 10 to the power minus 2 minus 5 times 10 to the power minus 3, right? So here, I'm going to look at the powers I have. There I have times 10 to the power minus 2, and there I have times 10 to the power minus 3. So again, they're different. What do? I pick the smaller number here, which is 2, right? So I'll factor out be times 10 to the power minus 2. So 2 will come in directly as a 2 because it was times 10 to the power minus 2, and that's fully represented by this 10 to the power minus 2 that's factored out. But 5 was 10 to the power minus 3. We factored out 10 to the power minus 2. So there's still another 10 to the power minus 1 remaining from the 10 to the power minus 3. So I'll multiply times 10 to the power minus 1. Now, if we work backwards here, 5 times 10 to the power minus 1 gives you 0.5. 2 minus 0.5 will be 1.5. Then I'll bring my times 10 to the power minus 2. In this case, the comma is between the first and second significant figure. So this is in standard form, and this is satisfactory. So try the questions on addition and subtraction in standard form. But one thing I can add is some people prefer a simple method of changing this whole thing back to its original form, and this one to its original or general form. So this would have gone back to 0.02, and this one would go back to 0.005. Some people would change these and subtract and then get their answer and then convert it to standard form. It's still acceptable. There is trouble, of course, when there's a bit of, when the powers are bigger, because you have to write a lot of zeros, but it's still acceptable for small powers. It's an acceptable way of adding or subtracting your numbers in standard form, so you can try the questions on addition and subtraction.